Good morning, teacher Jacqueline. We are the team of the project of the inverter of current. The team is integrated by Ivan Muñoz Loarca, Oribe Rodriguez Guillermo, and Alani Rodrigo Bansi Martinez. First, we have to watch to measure the resolution of issues. In this final part, it will note the problems that occurred in the generation of the project and also the resolution that we found to each part. At first, we have the wave train. Um, the wave train, or in this problem, we have to pass or go to the direct current to the wave train. How can do this? Um, the first aspect to consider is the duty cycle, and the second is the frequency. To get the duty cycle, we use the LM555 and the CD4047. The LM555, uh, we have to use three resistance and two capacitors. That this is very much that we can use in the CD4047. In the CD4047, we can use only one resistant and one capacitor, and form the wave train that we can that we need in the inverter. In this part, we can watch the laboratory proofs at the left, or well, yeah, at the left. We can watch the little circuit of the first part of the inverter, that is the wave train, uh, where we can watch in the second image the frequency and the period that we get in this proof. The most important aspect to watch in this proof is the duty cycle. When you can watch, the duty cycle is 48.8%, and the less is 51.2%. This is very, very closely to the 50% that we can find. Also, we can watch some other aspects, that media, the RMMs, the double bass, medium, max, min, and amplitude. And finally, at the right, we can watch the waveform that we can get in the laboratory in an oscilloscope.
Okay. I'm going to explain some issues in the process to convert the wave train to sinusoidal signal. How my partner Alani have mentioned it, we have a square wave train. So, and what we were trying to do was convert that signal into a sinusoidal one. That's where was some issues arose during the conversion process. Okay, since as mentioned earlier, the signal was square. We start proposing solutions to convert the signal. Okay, one of them was the LC circuit to obtain the desired signal. However, it didn't work as expected, and the signal became a triangular signal. So we continued proposing more solutions to to obtain the ideal signal. Okay. And finally, we proposed a type of filter that we had already worked with. It is the RC filter, which mainly consists of resistors and capacitors. And initially, we didn't obtain the desired signal, but thanks to a formula that we have applied, we found the correct value for the capacitor. And the most important of the project was the successfully achieved the required frequency, which was of 60 hertz.
Good morning, teacher. My name is Ivan, and I will talk about voltage and power amplifier. In this part, I will talk about the problem that we have with the voltage and the power that we describe in the objectives. At this stage, we look at for different alternative and kinds of circuits that will allow us to have a higher voltage and current out at the output of our circuit. This achieving the power part among them, and this is one example of one of the specific circuit that we use, and is the inverting amplifier. It's a configuration using an operational amplifier that is mainly characterized by the fact that its input is placed on input side of the amplifier. Other characteristic of this kind of circuit is that the input is placed on the inverting terminal and of the amplifier, and the non-inverting terminal is connected to the ground. Finally, this kind of circuit can make that at the output of the amplifier is obtained an amplified signal and at the same time that is inverse to the compared to the input signal. The other kind of circuit or more specific gadget that we use is the MOSFET. This kind of gadget in the different kind that we can see that is N channel, P channel, can make that the current get lower or less lower. It's a type of transistor widely used in the electronic industry for various applications, including the signal amplification, more specific in the current, switch, and current regulation. These applications and the signal amplification, switching and regulation current is directly in the part of the control in the electronic. This is all for my part.
Well, thanks, teacher. That was the current inverter for the use of electrical energy by means of solar panels project. Third, thanks for watching.